question B, paper 2. Okay, we will go through about the question. Semua dah ready? Guys? No guys ni. Tidur semua ni. Okay. Table 4 shows the apparatus setup and the observation two set of experiment to study the property of alkaline by using red litmus paper. Ingat, guys, in order to show the properties of the acid or alkaline, the water is compulsory because water shows the properties of the alkaline or the acid. Okay, let's look over here. Okay, let's do the first experiment. We try to understand what is the experiment is about, what happened. Okay, red litmus paper, and they put it on the dry sodium, solid sodium hydroxide. Of course, no changes because in order to show the properties, water is compulsory. Dia wajib ada air untuk menunjukkan sifat keasidan dia atau kealkali. Okay, and also you have a moist, because the first one is dry, a moist red litmus paper and a dry solid sodium hydroxide. This one, and the red litmus paper will change to blue, of course, because moist. Moist stands for it have a water, H2O. Therefore, the alkaline can show the properties. Therefore, the alkaline can show the properties of the system. Now, let's look the question. That is the theory. That is the theory about the alkaline and the acid. Now you look at here. Based on table 4, explain the difference in the observation for both set of experiment. Okay. Both set of experiment. Okay, 4 marks. 4 marks. This one explain the difference in the observation for the both of these. Okay, I'm gonna erase this. Okay, let's change it to this one. Jom kita tengok. 1 minute. I will really encourage my student to do this in a table form. You have a table, easier to compare. You have a set 1 and you have a set 2. I really encourage my student to do it in this one, guys, in a table form. So you know the first one doesn't have the changes, set 1. And the second set, you have the changes in the litmus paper. Okay, so in what happened? In the first one, how to explain the dry state. That's it. What happened? Yeah, that is the observation. You need to explain why. That is the observation. Yes. Why? Which ion you are referring to? Be more specific, Alisha. Very good. In a dry state, very good. The hydroxide ion in solid sodium, am I right? Sodium hydroxide are arranged closely boleh, orderly boleh, at a fixed position. Okay. So what if they doesn't have any free moving hydroxide? So what? This cause the dry solid hydroxide the not show alkaline properties. Yeah. Okay. On the other hand, okay, more or less dia akan tukar-tukar sikit je lah ayat dia So how to put it? When moist red litmus paper is used, sodium hydroxide ionized in water to produce free moving ions. So what happened? The sodium hydroxide shows alkaline properties. Okay, 4 marks to explain like this. Nampak tak? You just need to talk the role of water in this case. That's it. The role of water in this case. That's it. You get the full mark. Okay, done. Okay. In the dry state, they are fixed in position. Yeah, because in order to show the properties, girl, the OH need to freely move. And once it's freely moved, then it will show the properties such as alkaline properties. It can conduct electricity. Those are the properties when it is in an aqueous or liquid state. Okay, good. Rahil, are you okay, Rahil? Very quiet. Is okay. Okay. Kalau ada soalan, tanya tau. Jangan diam. Jangan bagi Aiman je buat tanya soalan. Sekejap lah, narik. Okay, let's look the next one, guys. Let's look the next one. We done with this? Okay. Look at the B. Another 4 marks. Wait, I zoom a bit. Okay. Try to answer this. Okay. As you can see over here, let's try to understand from the information. Why Alicia left? Oh my god. Semua pasal Aiman. Diagram 6 show the pH value of a 2 alkaline. Okay, good. So you have a beaker A with a pH 13. Guy, when pH 13, what can you say? Very good. It is a type of a strong alkaline. And the beaker B, you notice the pH is 11. Therefore, I can conclude it's a type of a weak alkaline. Okay, in this case, okay, of course, it is balanced with what is given over here. Ammonia is a NH3, and also we have a sodium hydroxide, which is NaOH. I think we have go through this thing. When I say a strong alkaline, it will undergo what? If it is a strong alkaline, it undergo a complete ionization. Do you still remember or not? Yes, it's undergo a complete ionization. If it is just a weak alkaline, please keep it in mind, it's undergo a partial ionization. Therefore, what does this stand for? When you undergo a complete ionization, you have the OH, the concentration of OH are very high. When you undergo a partial ionization, you do have the OH minus, but it's just in a very small amount. Okay. Once you know about the the theory, then we can proceed with the question. Explain why the pH value of both alkalines are different. Very good. I think most of the answer I already gave you. Just do it in a table form. Just do this in the table form. I will do it like beaker A and beaker B. Okay. I love if they ask you to compare like this, please do it in a table form because you will actually make the examiner to mark the paper easier. So you have a beaker A and beaker B. So what can I say? NaOH is a type of strong alkaline. Okay. It undergo a complete ionization. Therefore, it do have high concentration of OH minus. Okay. On the other hand, NH3, you just write it down, is a type of weak alkaline. It undergo a partial ionization. So it do have low concentration of OH minus. That's why this one pH value are very high and this one pH value are low. That's the answer. You get a 4 marks over here. Any question? Okay, you can screen capture this thing. Okay. Padam ya? Okay. Now you look at question number C. A much longer question. Okay. Wait. We try to understand what is the need of the question. Panjangnya. Okay. You are required to prepare a standard solution of a sodium hydroxide. Sodium hydroxide is a NaOH solution with the concentration of this is your concentration M, and using 250 this one volumetric flux, and the sodium hydroxide solution from beaker A in diagram 6. Okay. Apa ni? You prepare this and the sodium hydroxide. Oh, okay. Maksudnya, you need to do this concentration first. Then you need to do a dilution. A dilution. Okay. Because of what? Because of what? Guys, if you look at beaker A, it is 0.1 molar. Sekejap. Sekejap guys. This is 0.1 molar. Tapi sekejap. Kenapa soalan dia pelik Sekejap. Let's read the Malay one because pelik sikit. Sebab ini cair. This is diluted and this is concentrated. Anda dikendaki menyediakan satu larutan piawai. Wait, I read in the Malay version first. Larutan piawai hidroksida dengan kepekatan 0.02 menggunakan kelalang volumetric flux 250. Okey, itu tak ada masalah. Dan larutan natrium hidroksida dari bika A. Okey. I need to calculate the mole. Okay, sekejap guys. 1 second. We need to do the... Okay, let's look at here. Okay, I think I understood. Okay, macam ni you are using, guys, question dia adalah, you are going to use this to prepare this. The 0.1 becomes 0.02. Therefore, you are going to do a dilution. Pencairan. Dilution. What is the formula of a dilution? M1 V1 equals to M2 V2. This is your dilution formula. So, as you can see, this is your M1, the concentration before the dilution. And this is your M2, the concentration after the dilution. And the volumetric flux, the volume, is V2, the total volume after the dilution. So you are going to substitute those values into the formula. Then it is a dilution, and M1 is 0.1 and V1. I do not know how much I need to take up for the dilution, and I have the M2 0.02 and the total volume is 250. Okay, so change it to this one, guys, and you bring this one to the other side. The V1 will equivalent to 50 cm cubic. Do you understand or not? So write it down, this thing. Betul? Yes. It's already B, the 0.02. Yes. Tadi, when I read the question, I'm a bit confused tau dengan question ni. I myself get confused. Sebab I thought they want us to use 0.02 to prepare this. That is impossible. Sebab I just now read terbalik. Saya ingat macam mana 0.02 nak jadi pekat 0.1? Tak boleh. In dilution, yang pekat akan jadi yang cair. Then I understood is 0.1 becomes 0.02. The question are quite, not the question. I would say the word they are using are not precise. They cannot use standard solution. Standard solution is where you prepare with a very accurate, high accuracy. So maybe the question, the word, the use of word is not precise for me. But tak apa, ini adalah apa yang dia nak, kita buatlah 0.1 jadi 0.02. That is how it's happened. Okay, go. So now you look at here. Saya nak padam ni, saya nak padam. Okay, let's look over here, the question itself. Okay, name the method used to determine the volume of the sodium hydroxide. Is dilution. Dilution. I have put it over there. Okay, and also you calculate all the calculation. The M1 V1 equals to M2 V2. This is 1 mark. This is your second mark. And you calculate 50 cm cubic is the third mark. So you get 3 marks. 3 solid mark. Predict the pH value of the sodium hydroxide solution in the volumetric flux. Explain your answer. Explain your answer. Okay, boys and girl, look, okay, try to understand the question. I erase this. Okay, now you look at here. Here, this one is 13. 13 and 0.1 molar. After dilution, you notice the concentration becomes 0.02 molar. Do you think the pH value after the dilution will be remain the same? After dilution, do you think the pH value remain the same? Yes or no? No, definitely no. Why? Yes, where after the dilution, the amount of the hydroxide ion is decreasing. Less hydroxide. When you have less hydroxide, the pH value will be lower. That is the theory. That is the theory. So how should I put it into the word? Let's change it to the word, my dear student. So in the word, you already have the idea. So the answer will be the pH value is lower than 13. Okay, wait. Why? It is because concentration of hydroxide ions decreases after the dilution. Okay, then what happened? So you make a sentence, a conclusion. The lower the hydroxide ions concentration, the lower the lower the pH value. Good. Done. So you get 3 marks over here. 1, 2, and 3. Actually kan dia tak susah tau. You have explained this. You understand the theory. Most of the students have a difficulty to change the idea into a word. That's the most difficult part. Some of the students have a difficulty. But look at that. You already explained. Once you do the dilution, the OH concentration decreases. It affects the pH value. That's it. Okay, you can screen capture this thing. You can screen capture this thing. Okay, I'm gonna erase this. And back to the question. Let's look this one, yeah? Okay. Okay, this is a quite long question. Jangan salah. Let's understand the questions clearly. Okay, 25 cm cubic sulfuric acid. So I have H2SO4 over here. Is needed to react completely with this thing, sodium hydroxide. So this is your NaOH. Okay, NaOH. Okay. State the type of reaction occur when you have an acid and you plus with the alkaline. What is the name of the reaction? Tell me. Very good. So I will write it down over here. It is a neutralization. It's a neutralization. Okay, guy. Okay, this is already 1 mark. Let's look at the next question. Done with the first one. Write a balanced chemical equation for the reactions. Okay, you have H2SO4 and you are reacting with NaOH, and this will give you Na2SO4 plus H2O. This is not balanced. This is not balanced since you have a 2 over here. And wait, is this balanced? Oh no, 2 sodium over here. You place a 2 over here. Then you have a 2 plus 2 is 4. Then you put a 2 over here. Is this balanced? Is this balanced? Yes, it is a balanced equation. You might get 2 marks over here. Okay, now you look at the question again. Balance equation done. Now calculate the concentration of the sulfuric acid used. My dear, this is a neutralization. When you are dealing with neutralization, you're going to use this formula MaVa over MbVb equivalent to A over B. A over B. This is your equation, formula that you are going to use. Okay, few things that you might come across. Listen here, guys. First of all, what is the A and the B value? What is the A and the B value? The A is equivalent to what? This is your A, am I right? Acid. And the base. Look, this is your A. A stand for acid. B stand for base. You are going to look the value. In front of the B, you have a 2. In front of the A, you have a 1. Therefore, the A is actually 1. And the B is actually 2. 1 over 2. Guys, are you understand? Okay, good. Kalau yang tak faham, tanya So you have MbVb. Ma is what you are looking forward. Vb, let's look the Vb. Is that given in the question? Vb. Va. Yes, it's given. Is equivalent to 25 over weight MB, the concentration of the B. 7C. What is the concentration of the prepared one? Very good. Then you know 0.02 and the volume is given as well. I think yes, over here. The volume is 25 and equivalent to 1 over 2. Guys, please solve this mathematic formula for me. What do you get? Very good. 0.01 mole dm cube. This will be your answer. Ya, ada tak siapa-siapa tak faham? Anyone?